Lecture 6, Error Propagation. Errors are present in all kind of measurements, such as orientation of planes and lines, and thickness of a layer. Therefore, it is very important to know how to handle these errors and include them in operations. This is called error propagation. Let's look first at sums and differences. If two quantities x and y are measured with uncertainties delta x and delta y, and their measured values are used to compute a sum or difference. The uncertainty in Q is the sum of these quantities' uncertainties. Let's look at products and divisions. If two quantities x and y are measured with uncertainties delta x and delta y, and their measured values are used to compute a product or division. The fractional uncertainty in Q is the sum of the quantities' fractional uncertainties. All these cases are summarized by this equation. The uncertainty in Q is equal to the partial derivative of Q with respect to x, times the uncertainty in x, plus the partial derivative of Q with respect to y, times the uncertainty in y. This is the maximum uncertainty in Q. It assumes the errors are correlated. However, if the measured quantities are independent and random, as is often the case in geology, we need to use instead a quadrature error formula like this. This table shows the error in quadrature, sigma, for common functions or equations. You can use this table to compute the error, whenever you encounter formulas like these. In the class, we will do exercises about error propagation and introduce a Python library that facilitates this. Please read these sections from Reagan and our Computational Geosciences resource. And answer these questions.